Let me start. So, as you know, AI is evolving at an unprecedented pace. And in this presentation, I'm going to discuss how we're staying ahead of that curve at AMD to enable the next wave of AI when the pace of innovation is faster than the pace of building hardware. And we're doing that based on open foundation. So that's open software, open source software, open hardware, and even open platform, basically racks based on open standards. And I'll cover how that enables us to build much faster the compute capacity needed to run AI at scale. And also, I'll cover a little bit on how this helps sovereign AI. So first, in the past 5 years, AI has evolved from the famous ILIA from OpenAI scaling law that he published in 2020. And that scaling law basically showed that the intelligence of an AI model is basically proportional to the log of compute you put in it, or the log of the size, the number of parameters. And that law was true for about 4 years. And that also meant that models were increasing exponentially year after year after year. So more parameters, doubling the parameters, but doubling the amount of data also you needed to compress in those parameters, up until we ran out of data. We ran out of publicly available data to continue to scale those models. So what is intelligence now proportional to? It's still proportional to the log of compute, but it's no longer compute in pre-training. It's compute in pre-training, in post-training, and in inference. So what happened is that inference evolved from a one-shot prediction of a sentence or one-shot prediction of word by word of a sentence to reasoning model. Now, models are actually more verbose. They reason, they create different chains of thoughts, and they assess which chain is the right one, and then they give the response. So they're just trained to be extremely verbose and try different chain of thoughts. And pre-training, post-training is also a thing now for domains that are verifiable. For example, in math, you can actually solve a math problem and re-inject the result in the initial problem to see if you got it right. And models are training by doing this until they get it right. Same for coding. The reason why models are so good at coding today is because they take a problem, they generate the code, and then another model would compile the code on a CPU and run it and verify the output. And it would learn by reinforcement learning. So it would reinforce the behavior if the code is right and punish it if it's not. But all in all, the compute done in pre-training, post-training, and reasoning inference is still proportional to basically intelligence. The log of that is proportional to intelligence. And at AMD, basically, we have data center CPUs and GPUs on the left that are used by the likes of OpenAI for ChatGPT, Meta with their Llama inference, and other X.AI with Grok inference. But also at the edge and at the endpoint, we have laptop chips and embedded chips that go into cars and satellites and the rover on Mars and medical equipment that are also capable of inferring AI model, and including now reasoning models. In terms of the data center GPU, so the GPUs are actually completely neck and neck in performance with the NVIDIA GPUs year after year. So we have this roadmap. Right now we're at the MI350 and MI400 coming in 2026. And starting with MI350, we're building full-scale racks also that some of the CSPs present here are already deploying. And if you look at those racks, there's some crazy number on the memory side. That's our biggest advantage is the HBM memory, where we're 2.8 times higher than the equivalent Grace Blackwell NVL72. So huge advantage in HBM and some advantage in compute as well. And of course, the next generation rack also coming with MI400. So in terms of software, really the strategy to run really fast at the speed of AI innovation is to completely work with open source. Like we have no closed source. Everything is open. The equivalent of our CUDA is called ROCm. It's completely open. It's inside the PyTorch source code. So we work with obviously PyTorch, which is the predominant framework for LLMs, but also JAX, ONNX, and all the other framework. The other important one is Hugging Face, which hosts 1.8 million models. So we work very closely with them and provide them with compute to do continuous integration and continuous development of their software stack and the LLMs that they host to make sure that the 1.8 million model go through, and they all do. And also OpenAI actually writes open source software. So OpenAI Triton is a language. It's a compiler for what we call kernels, which are the basic building blocks of AI models. And Triton basically enables developer to write optimized kernels, so LLMs run much faster. And we also work very closely with OpenAI to make sure that Triton fully support our GPUs. So, and on the inference serving side, we support, you can see in the middle, VLLM, SGLang, and LLMD, which is what companies are more and more using. They're open source, but that's what companies are more and more using to infer LLMs on a lot of GPUs. So they may have tens of thousands or hundreds of thousands of customers inferring several models on thousands of GPUs. And you want to make sure your GPUs are used optimally, otherwise you're going to lose money. So those are the framework that enable that, VLLM, SGLang, and LLMD. LLMD, the D is for distributed inference. It's actually something that came about, I think, with DeepSeek. They figured out that by disaggregating prefill and decode, so prefill is basically the prompt analysis, and decode is the generation of the answer. By disaggregating the GPUs that do prefill and the GPUs that do decode, we actually get higher performance. So LLMD is now specializing in that, in disaggregating prefill and decode compute. And that actually enabled DeepSeek to get very significantly lower price per token than OpenAI. And since then, everybody's doing that, and that's the way to do it. So just to give you an idea, by us putting all of our resource to work with the open source community, we get results like that where when Blackwell came out, MI355X, our Blackwell came out pretty much at the same time. And because we're focused on open source and we work with them exclusively, we had 1.3x higher performance than Blackwell because they're working on their closed source TensorRT LLM, which at the time we did that benchmark, TensorRT LLM didn't even support FP8, they supported FP4 only. That's just to show you NVIDIA being a much bigger company and having a lot more developer. That just to show you the power of the open source community, which obviously is worldwide and significantly bigger than NVIDIA or AMD. By working with them very closely, we can actually move much, much faster than relying on our own engineers. I talked about disaggregating prefill and decode. This is really how it works. Up until DeepSeek, people were inferring LLMs by doing prefill, so prompt analysis and decode, so generating the answer in the same GPUs. And since then, everybody is trying to disaggregate and put maybe few GPUs to do the prompt analysis and a lot more GPUs to do the decode, especially with reasoning models. Decode is becoming very, very compute intensive, so you want to put more GPUs to do that. So there is this thing called the KV cache, which is basically the context of a chat. And the initial context is generated by analyzing the prompt. So prefill generates the initial KV cache, and then decode just augments the KV cache with the next word and the next word and the next word. So basically how the disaggregation works is that the prefill GPUs calculate the initial KV cache, put it on a shared disk, and then it's sent to the decode GPU that then generate the next sentence. And that has to be done at very high speed and very low latency. And that's the difficulty that VLLM, LLMD, and SGLang are solving on our GPUs. This slide formatting didn't go too well, but the next level that we're supporting is enterprise AI. And that's basically once a company or a sovereign nation is buying a lot of racks, great, they have a data center with a lot of racks. Now, what do they do with it? So they need to be able to run an entire software stack that can distribute jobs to the GPUs and maximize utilization. So using Kubernetes, using VLLM or SGLang, LLMD, and so on. And that's and be able to do the telemetry to see what's the usage of my GPUs and what are the GPUs that are not running and why and so on. And that's the stack that we're providing in the second half of this year to enterprise and sovereign nations. In the other hand, for sovereign nations, we already have enabled quite a few national labs, both in HPC and AI. And those are some of them. So Oak Ridge and the National Energy Technology Laboratory, they basically hold the #1 and #2 fastest, biggest supercomputer on the planet. And they're based on AMD GPUs. And that's really for HPC. So it's massive data type, FP64. But they also do use those to do AI training. And Lumi is the #1 supercomputer in Europe, which is also based on AMD GPUs. And it's also used for HPC and for AI training. Silo AI was the biggest AI startup in Europe based in Finland. They heavily relied on Lumi. And they're now part of AMD, so Silo is also helping us now work with the different nations. In France specifically, we have deals with the CEA and Gensi that are using our GPUs now. And if you look at the bottom left, there is a G42 logo. That's a company in the United Arab Emirates, but they are building a massive data center. It's close to a gigawatt, I believe, in Grenoble, France. So that's going to be a super big data center in France as well, based on these GPUs. And we announced a big deal with Saudi Arabia and other nations as well. And I think it's really important that countries adopt compute, and probably it's smarter to adopt it with 2 vendors rather than 1, to not get stuck with a vendor that dictates the prices and dictates the schedule of when you're going to receive the GPUs. The way I like to think about why it's important for nations to own their own compute is that AI, as you heard it many times, is the biggest revolution since the Industrial Revolution. And when you think about the Industrial Revolution, some countries went full speed ahead in it, like European nations and the United States, and some countries that were extremely big and successful economies before the Industrial Revolution, like China and India, didn't go full step ahead in that Industrial Revolution, and that really set them back a century or two. And now they're back, and they're fully adopting AI, and there is a reason for that. They see what's coming, and France, thankfully, is finally adopting the sovereign AI as well. But I really believe it's really, really, really important for countries to fully adopt AI, because it's, if you're thinking this thing might be hype, let's think about it that way. It's the first time in human history, in human history, that there is an intelligence on Earth that competes with human intelligence, which is not human. And we know that this, over time, that intelligence will become human and will become superhuman. And it's really the first time on Earth that we have that level of intelligence. This thing is not hype, and the same thing that happened with the Industrial Revolution will happen with this technology. I talked about Silo AI, so they're local here in Europe, they're in Finland, they're working with a lot of the European labs, also enabling them with AI workloads. So that's about it. So that's my last slide. I just wanted to say that the future of AI is open. We believe it's open, it's not closed. So that's why we're enabling open source software, open platform, open standard like OCP racks and Ultra Ethernet and UL Link, which are basically open ways to do scale up, scale out, and rack designs. And we're basically enabling right now companies like OpenAI, XAI, Meta at scale. And we're doing a lot of developer events to empower developers. And if you are a developer, you want to scan that, and we'll give you several hours of free compute on our GPUs, which are, again, fully compatible with Hugging Face, PyTorch. Anything you do with any other GPU, you can do it the same exact way with that. So you just scan that, and we'll give you an account with several hours of free compute. And we can renew it if you contact us and if you run out of those. OK? Thank you very much.